For problem 156, it's asking us to compute the line integral of v is equal to 6x hat plus yz squared y hat plus 3y plus zz hat along this triangular region. And in order to do that, we have to know dl is dx x hat plus dy y hat plus dz z hat. And one tool to use is along this diagonal, z is equal to 2 minus 2y. And then we also have to take each line integral because there's 3 different paths we have to take in order to get the closed loop. And then we have to verify this using Stokes' theorem. So our first step is to take the first path, and along this, x is equal to 0 because it's on the x and z are equal to 0 because it's on the y-axis. So dx and dz are 0. So v dot dl is yz squared y hat dot dy y hat, which is yz squared dy, which is 0 because z is equal to 0. For our second path, x is 0, dx is 0, x doesn't matter. So we want to use a substitution. Z is equal to 2 minus 2y. So dz is going to now be minus 2 dy, and y is going from 1 to 0. V dot dl is now yz squared y hat dot dy y hat plus 3y plus z hat dz z hat. So yz squared dy plus 3y plus z dz. So when we take our v dot dl over path number 2, it's going to be this y times z squared, but z is 2 minus 2y, so we have 2 minus 2y quantity squared dy plus 3y, and then I put this in its own little parentheses, 2 minus 2y, and it's multiplied by minus 2 dy due to the substitution we used for z. And then here I just expanded it out, and it's going from 1 to 0 as defined by the line, because we're going from a point on the y-axis to a point on the z-axis. So y, and then 2 minus 2y squared is 4y squared minus 8y plus 4 dy. And so I just combine the term here. 3y minus 2y is y, so y plus 2. And then I still have to multiply by this negative 2. So integral from 1 to 0, 4y cubed over 8y squared plus 4y dy plus the integral 1 to 0 of negative 2y minus 4 dy. But we could just add them all together, and we get the integral from 1 to 0, 4y cubed minus 8y squared plus 2y minus 4 dy. And just evaluating this integral, just using basic power rules, we get y to the 4th minus 8y cubed plus y squared minus 4y. And doing some arithmetic and rearranging, this entire thing turns out to be 14/3, which is kind of hard to write, so I'll rewrite it right here, 14/3. So now for line number 3, we have x is equal to y. Because we're going along the z-axis now, x is equal to y is equal to 0. Dx is equal to dy is equal to 0, and z is going from 2 to 0. So our v dot dl is now only in the z hat component. So 3y plus zz hat dot dzz hat is equal to 3y plus z dz, but y is equal to 0, so it's z dz. And this is from 2 to 0. Our integral is from 2 to 0 z dz, which is z squared over 2, evaluated from 2 to 0, which gives us 0 squared over 2 minus 2 squared over 2, which is just minus 2. So for our closed loop integral, it's v dot dl, which is equal to path number 1, which is 0, plus 14 over 3 minus 2. But we can make that even better, because even more simplified, just multiplying the 2 by 3 by 3. Multiply the 2 by 3 over 3, and then we get 14 minus 6 over 3, so we get 8/3. Now, to verify this using Stokes' theorem, we're going to take the curl of V and dot it with dA. So I like to compute the curl explicitly for this problem, because it's a Cartesian coordinate and it's really easy to compute it. So in order to compute it, we need a 3 by 3 matrix, which is in the first column. The first row is all the unit vectors, x hat, y hat, z hat. And in the second row, it's the del operator, which is all the partials, partial by partial x, partial by partial y, partial by partial z. And in the third row, it's our v, which is 6, and then yz squared, and 3y plus z. So when we find the determinant of this matrix, it's broken up into 3 2 by 2 matrices. And in order to find these, we take the 2 by 2, we use the cover-up method, and this is identically the x hat matrix. And in order to find these now, we just cross multiply. So partial by partial y of 3y plus z minus partial by partial z of yz squared. And this is the x hat component minus partial by partial x of 3y plus z minus partial z of 6. And this is the y hat component. And this is plus partial by partial x of yz squared minus partial by partial y of 6. And this is the z hat component. So when I evaluate all of these, this is equal to partial by partial y of 3y plus z is just 3. And minus partial by partial z of yz squared is 2yz x hat. And partial by partial x of 3y plus z is 0. And the partial z of 6 is 0. Partial x of yz squared is 0. And the partial of y of 6 is 0. So we only have x hat component for our curl. So that's good. So now that we found our component, 3 minus 2yz x hat. We have to find our dA. In these types of problems, we want to know which way are we integrating. And, well, it has to match up with our directions. So it has to be an x hat component because we're taking a dot product. And when we do this, it's dy dz. So we integrate 3 minus 2yz dy dz. And we're going from y is equal to 0 to y is equal to 1, and z is equal to 0 to z is equal to 2 minus 2y, because it's along that diagonal path. So we should rewrite this so that we have our dz first. So it'll look like that. Now we just integrate this, so 3z minus 2yz squared over 2. That cancels. And then we're just going to evaluate. So 3 times 2 minus 2y minus y times 2 minus 2y squared. That's 6 minus 6y minus, and we did this earlier. The y times 2 minus 2y quantity squared. We did this entire expansion earlier. So now I just combine all the like terms. So now I integrate, and I get minus 4y to the 4th over 4 plus 8y cubed over 3 minus 10y squared over 5 plus 6y evaluated from 0 to 1. No. Oops, that's not a 5, that's a 2. That's a 5. Sorry. So now I get minus 1 to the 4th plus 8 over 3, 1 cubed, minus 5 times 1 squared plus 6 times 1. So 8 over 3 minus 5 minus 1 plus 6. Our total is 8 over 3. So our closed loop v dot dl line integrals was equal to 8 over 3. And using Stokes' theorem to compute the curl dot dA was equal to 8 over 3. Since they're both equal, we could say that it's verified. Thanks for watching.